What? Who's with me?
I'm lonely.
I drink too much coffee.
Oh man.
I drink a whole.
All right, what should you have out right now? Let me see.
Multiplication.
Oh, we should definitely have our multiplication chart, but nobody had it out already.
Heavy.
I'm so
What do you mean I don't have it out already?
Oh, look at you. Oh, Javier had it. Okay, so in your multiplication charts, you should have a marker. Who can tell me what we have been working on? Naomi.
Fractions.
We've been working on fractions.
Adding, subtracting.
Let's go underneath this table.
Adding and subtracting.
Who is it?
yours.
No, grab it.
No, because I paid you 20.
But you threw it on the floor, so you gotta pick it up.
Put it right here.
We'll grab it off the floor. Okay, we've been working on fractions. What have we been doing with fractions? Adding and subtracting. And what do we know if we are adding or subtracting fractions?
You have to have the same denominator.
You have to have the same denominator. Thank you. Did you erase this? Okay. So we have to have same denominator. What's another way we could say same denominator? Ooh, sorry, Javier.
Equal.
Equal. So if we're using our mathematician words, we have to have equal denominators. And which number is our denominator? The top number or the bottom number?
Bottom.
Oh my gosh, everyone give yourselves 10 points.
The numerator.
Oh, bonus 5, Gwenny. So everyone gets 10. Gwenny gets 15. Okay, so what is a strategy we have been working on? If Mrs. Reister gave you this problem, what can you tell me right away? They don't have the same denominator, so we cannot add them like this. What is a way we can rewrite this problem to help our brains first?
Opposite denominator.
Well, yes, but how can we write this problem? How's it written right now?
Diagonal.
Not diagonal. It's written, no, how's the sun come up over the horizon? So this is horizontal. What is a way that helps our brains solve these problems? Vertical. Or we can also call it stacked, right? Okay. So, right off the bat, we know that we can't add them because they don't have what? Same denominators. So, what can we do?
We have to see if they have something in common.
We have to see if there's something in common. What do we know about 7 right away?
That it's a prime number.
It's a prime number, okay? Then we have our 10.
And 10 is not a prime.
And 10 is definitely not a prime number. Nice job, Gwenny. So, what do we think? We have to either see what they have in common or
They have 70 in common.
they have 70. So what does that mean? We have to multiply by the...
Opposite denominator.
Okay, so what's the opposite denominator from 10? Or 7?
10. I gave you the answer.
And whatever I do to the bottom?
You do to the top.
Okay. Then down here, what's my opposite denominator from the 10?
7.
7. And whatever I do to the bottom?
You do to the top.
Okay. Draw your bars right next to it. So, what is 7 times 10?
70.
Oh, I want whole group. What is 7 times 10?
70.
Okay, give yourself 7 points. Then if we look at our top number, what's 3 times 10? And everybody better answer me.
30.
30. 3 times 10 is 30. Oh man, this answer might be a big one. Now we go to the bottom. What's 10 times 7?
70.
70. And 1 times 7?
7.
And we can do ones really fast because we know that anything times 1
is itself.
Okay. So what's our operation? What are we doing?
We're adding.
We're adding. And do we add our bottom numbers?
No. But
Our bottom number,
stay the same.
okay? So we're just adding our top numbers. So what is 30 plus 7?
37.
37. Now, what do we need our brains to do before we go on?
See if they can see if they can go smaller.
Now, what's our math word for that? See if the fraction is in blank form. What form is it? Not equivalent. Ooh, Kelly, preach it a little louder. Simplest form. Hold on.
This marker's died.
Alan, is that okay if I open this?
This marker kind
Yeah, I know. I think some of our black markers are at their ends. So, let's see. what do we know about 37? Can we see if it's even? Yep, you have to stay in school too, just like me. Is 37 even?
No.
How do you know it's not even?
Because it doesn't end with a 2, 4, 6,
Or
8.
Or a
0.
0. So it doesn't add in any of those. So it doesn't, 7 doesn't go in it. Or excuse me, 2 doesn't go in it. Let's look at 3. If we find our 3 and go down, does that go into 37? Nope. Let's try our 5, because we know 5 goes into our 70. Does 5 go into 37?
No.
Nope. So, is this in simplest form?
Yes.
Yeah.
That's as
It's
small
done.
as I can get.
That is as small as you can get.
Teeny tiny.
Ah! I have to
Just
stay.
pretend that you
2
made it.
plus years every time you make
I know. I'm gonna just stay in school too. Okay, so let's try another one. What if Miss R gave you this?
Why do you know? Why do you
Markers.
go like right to our book? How do we have to work?
Because it's gonna do review problems first, chickadee. Okay, who can read my problem to me? Maya.
5, 6, minus 2.
Thumbs up or thumbs down? Do we agree with Maya? Javier says yes. Alan says yes. Naomi says no. I think Naomi being funny. And Gwenny says 2 thumbs up. If you said yes, give yourselves 5 points because she was correct. 5, 6 minus 2/3. Okay, what's our operation? What's it telling our math brains to do?
I also said myself is good. What do we have to do?
Yep.
See if
What's my operation?
minus. Oh, minus it.
Minusing. Okay.
So if you can see if it's smaller.
Are they on the roof?
They probably have a dance party. They probably have a dance party. Listen to them.
A little creepy.
That is creepy. Oh no, I think it's this. Look at. They're brushing the sidewalk. That was a squirrel moment.
Squirrel?
See, they're washing the sidewalk.
You're getting the salt off,
Mm-hmm.
which it needs it.
Yep. Okay,
That's loud.
class.
Yes, yes.
So, Naomi and Maya told us our operation is minusing. So when we're minusing fractions,
That's
what
to
do
get
we know?
smaller.
What?
That's to get smaller.
Well, it's in getting it smaller is what we do at the
They have
end.
to have the same
They have to have same denominator. How can we write this problem to help our brain solve it better?
Stack.
Stack it. And if we're using our fancy math words, it would be called putting it in vertical form. Good. When we are writing a subtraction problem, does the order matter?
No. Yes.
Yes, it does. What about when we're adding? Does that order matter? No. What about when we're multiplying? Does that order matter? No. What about when we're dividing? Does that order matter?
Yes.
When we are dividing or subtracting, our order matters. When we're adding or multiplying, it does not. Yes, Ms. Cooper?
Just hit me, whenever your number, when you divide, your number is smaller. When you subtract, your number is smaller. It matters when you're,
Mm-hmm. So when our operation
is
is having
smaller.
us get our numbers smaller, the order matters. Okay, so now we're subtracting. What do we know about subtracting fractions? No, you have to have common denominator. So the first thing we can look at is, does our smaller number go into our bigger number?
Yeah.
Oh, I see Maya nodding.
Yes.
Yes, it does. So do we need to change this fraction at all?
No.
No.
Nope, he stays the same, 5, 6, you can just carry him over or you don't have to rewrite them. But now, what do I need to multiply 3 by to get to 6? 2, and whatever I do to the bottom,
Do to the top.
point. So, what's 2 times 3?
Times 3 is 6.
And then 2 times 2,
4.
okay? What is my denominator gonna be in my answer?
6.
Because our denominator stays the
Same.
okay? And then 5, take away 4 is 1. And we already know, okay, so where your brain's at right now, we gotta make sure that our fraction is as,
Small as it moves.
And yes, I can because one is a prime number.
because 1 is prime. And 1, can you get any smaller than 1?
No.
No.
So do we already know right off the bat this is as small as it gets?
Yeah.
Yep, that's it. Okay, we'll try 2 more and then I'm gonna set you free so you can finish up your worksheets. Nope, Alan, you're still working on IXL. Ooh, and you wanna know what else? I think today,
Today what?
No. Say you guys say in school too.
who thinks they can come up and do this one? Naomi, get it, girl. So let's watch Naomi. So Naomi first, how is it written?
What is this?
Horizontal.
It's written horizontally. And what helps our brain to solve this?
To make it up and down.
To make it up and down or to make it stacked or vertical. Good. Give yourselves 2 more points. Good. Oh yeah, that's good. Do what? Okay, so thumbs up or thumbs down. Do you agree with what Naomi did? Alan's showing me nothing. Javier says yes. Gwen, do you agree?
Yeah.
Maya agrees. Did she keep them in the same order? When we're adding, do we have to keep them in the same order? No. But is it still good to just transfer it down in the same order? Yes. Good. Okay, so now, who can help out Naomi? What's she got to do? What's our operation? What's our operation? Oh, we're not subtracting. What are we doing? Adding. And so if we're adding fractions, we have to have
Same
denominator. So draw your lines right next to it, Nene, so that we've got it prepared. Now you have to think, what do 2 and 9 have in common? First, we should see if our smaller number can go into our bigger number. So look at 2. Go down 2. Does 2 go into 9? Javier, say it louder. No, it does not. 5 points, everybody. It does not go in. Nene, give yourself 5 points. So we know that 2 can't go into 9, so that tells us we got to find something that they have in common, or
The opposite denominator.
worst comes to worst, it's opposite denominators. Does anybody have an idea yet?
The opposite.
Naomi is saying opposite denominators. Does everybody else agree?
Yes.
Y'all are correct. Give yourself another 5 points. Naomi, say out loud so you're instructing your classmates, because it's important you learn from me, but also from
each other.
Good. Another 5 points. Kelly, will you put plus 10 next to Naomi's? Just put plus 10 there.
Okay. So,
So check it out. So so say what your opposite was.
to 9 it was 2, and then to 2 it was 9.
And whatever you do to the
You do to the bottom.
okay, so now go straight across. It is 18. Nice work. Did you do that one in your brain?
Yeah.
Naomi! Guys, why is it important that you might memorize your multiplication facts? If you don't have a multiplication chart by you. Also, what did Naomi just do? She said, I gotta see what 2 times 9 is, and it's 18. She did mental math. How fast was that? Like 1 second. She was like, boom.
And 1 times 9 is
And 1 times 9.
And then this would be 18.
2 times 7. Yes. Yes. Nice work, Maya. Okay, so check out Naomi's problem now. It says 14/18. It's okay. Is it still recording?
Yeah.
Yeah,
I think
we're
so.
good. I have to record for Mrs. Goschke for my ASD endorsement.
Well,
Setting
I'm
her
over
video.
here.
Wait, so
You know her.
Okay,
so
but-
they're not sending this to school, so if we do something embarrassing, they'll.
Then the whole early elementary is gonna know.
Oh,
They're gonna be like, dang, those 5th graders, they cry. Okay, check out Naomi's problem. She has 14/18 plus 9/18. So what's she gonna do?
Make the denominator
The same at the bottom, yep, and then she's gonna add what?
the top.
The top.
denominators.
So what is
Denominators.
14 plus 9? Try one more time. Yep. Ooh, Mercedes, say that louder. I like how you read that.
23:18.
That is how you read it. 5 points, Mercedes. 23/18. Now, in our brains, we have to think, can I make this any smaller? So, are both of our numbers even?
No.
I see Maya shaking her head. No. Because is 23, is that even?
No.
So we can't divide them both by 2.
That's a prime number.
So if we think about 18, we have, and we factored out, we've got 1 times 18 is 18. 2 times 9 is 18. We already know 2 doesn't go into 23. Does 9 go into 23? Find your 9. Nope, Maya's saying no, Kelly's saying no. So then we have 3 times 6 is 18. Does 3 go into 23?
No.
Does 6 go into 23?
No.
No, it goes into 24, but not 23. So it is the simplest it can be. Now, at the end of this week, we're going to talk about this. Is there something you notice about this fraction that's unlike other fractions that we've done?
It goes over the
So our top number, our numerator, is bigger than our denominator. So we haven't talked about this, and I don't want to touch on this because I want you guys to finish where you're at, but we're going to work on this later in the week. This is called an improper fraction. Have you heard about these before?
Yes.
Yep, last year, yep. Concepts keep coming back, you guys. They keep repeating. So an improper fraction, I'll just show you what we would do to simplify this, is we would make it into a mixed fraction. My denominator stays the same, so I bring it over, but then I pull out an entire 18 out of here, because we know if I gave you this fraction, what does that equal? 1 whole, right? So when you have an improper fraction and your top number is bigger, that means there's a hole inside of there that we can pull out. So we pull out 1 whole, so that's my big number, and then I subtract what's left over. 23, take away 18. I can't take 8 from 3, so what do I need to do?
Knock that on paper.
I come to my 2, I say, hey, can I borrow a 10? And he says,
Yeah.
he becomes a 1, 3 becomes
13.
13. 13, take away 8. You can put 13 in your
5.
brain, 8 in your feet. Okay, it's 5. And what's 1 take away 1? 0. So my numerator, or my parts that's left over, are 5.
1/5.
So we wouldn't do the 5th here, we just do 1 and 5/18. And we put that nice little word and in here. So you'd say 1 and 5/18. Okay? But mixed fractions and improper fractions, that was just a little taste of what's coming, so don't worry. That's not what we're doing today or tomorrow.